Hello. So for this session, we are going to talk about using the LCD with our 8051 microcontroller. Okay, so by using the LCD for microcontroller, it's the same thing as using any other device with the microcontroller, where you have to make the proper connection and do the proper driver coding so that the LCD will work to your microcontroller. So here, let me jump into our design. Okay, so this is the design that we are going to use in our labs. Okay, I've selected the LCD. If you look, you can find the LCD code in libraries. Okay, in libraries. Okay, find the LCD button. Okay, you can find the component. Just type in LCD. Footprint is Condil 14. The model is LCD Alpha. Okay, so if you type in the library LCD and then optoelectronics, so what we want is a 16 by 2 LCD. Okay, 16 by 2 alphanumerics LCD. Okay, LM016L. Okay, so just select those. Here I already selected mine. Okay, so just I think you can set. So I selected LM016L LCD, 16 by 2 LCD. 16 by 2 means that the LCD is a 16 character LCD and have two lines. We have the upper line and the lower line. It is 16 by 2 and two lines. Okay, so by selecting this LCD and make the required connection, if you look here, we need to connect VD to power supply. Okay, and VSS is connected to ground. And then VE voltage, some of the book says that VE are used to adjust the backlight LED or the lighting of the LCD. So that's why the VEE is connected to the potentiometer. Okay, so we are using a 10K potentiometer here to connect to the LCD to adjust the brightness of the LCD itself. Now and then connect the enable and reset button to the microcontroller. Enable pin 6 of the LCD is connected to port 01, and reset button is connected to port 00. Yeah. Now what else? Okay, and then if you look at the connection to the microcontroller board, due to the fact that we are using port 0, we have to make an active we have to make the microcontroller pin of 00 and 01. We have to put a pull-up resistor to pull up the resistor current, to pull up the voltage current for RS and RE connection. So this is the pull-up resistor. Okay, and then for the data in, we have D0 to D7. We are connected. D0 and D7 are connected through the microcontroller throughout port 2. Okay, so now and then you may see the other connection. This is the typical connection of the 8051. We've done this before in our other circuitry, so just remake the connection again. Now for the LCD, after you're done connecting all the required part of the LCD, D0 to D7 are connected to part 2, enable and reset are connected to P0 and P1 respectively, and right are connected to ground. VSS is connected to ground, VDD, the power is connected to power, and VEE is connected to power via the voltage variable resistor to adjust the backlight lighting of the LCD. Now let us look into the code for the LCD. For the code, I put the code and the design of my circuit and the code for the LCD in our Proteus 8, in our UniKL VLE system. You can download the code and the schematic there. So let's look into the code. For the code, I've done what we usually done in our lab. We done it in a header file format. So this is the header. We are using register 52.h for the microcontroller. We are including, this is a new header file, lcd.h. You can find lcd.h in the folder that I've given you when you download it from VLE. Just include the lcd.h inside the same folder where you save your code, and then we need again include delay.c, the same folder delay.c that we have used before. Just include it because we need to have delay here in our LCD programming. Okay, and then we make the code connection here, the LCD module connection. This is following the connection that we have in our Proteus. Okay, this whole connection. Okay, just follow that connection and do the LCD connection. If you look at the comment I've given here, this is to connect the LCD for the 8-bit module or the 8-bit connection. Surprisingly enough, the LCD we have two types of connection. We have 8-bit and we have 4 bits. If you are using a 8-bit connection, that means you are using D0 to D7 to send data. If you are using 4-bit connection, you are using D0 to up to D4 to connect the data. It's not that much different between the 8-bit and 4-bit. It's just that using the 4-bit, you are actually reducing the connection needed for the microcontroller and the LCD. And besides, it just needs a minor coding alteration to use a 4-bit and a 8-bit. So for this example, we will stick to the 8-bit connection first. Okay, so going down for the LCD module connection. Okay, using the LCD module connection, in the main program, okay, initiate this I is used for the counter. LCD initiate 8 is because we are using include.h, so we need to initiate the LCD 8 initiation. That means telling the header file that we are using the LCD 8 initiate LCD 8 connection. Sorry. Now, and then while one forever loop. Okay, clear the LCD. We don't want any bugs or anything prior to what we want to write in the LCD. And besides, because we are using while one, we don't know what's going to be the follow-up to the LCD before we write our code. So clear the LCD and then select the cursor position. The cursor position here is 1, 1. Means that we are selecting line 1, position number 1 here. This is going to be the starting point of the LCD writing. Now, LCD write string, write the word hello, LCD hello world. So we start to write a string of letters, okay, to the LCD saying LCD hello world, and then we are going to shift the LCD to move from right to left. So we are going to use LCD shift left. Delay, so that means it will delay for about 1 second before it shifts to the left for each character displayed. And then after it done delay 15 times to the left, we want to shift it back to its original position. LCD shift to the right, back another side, back right to the from right to left, another 15 position. This is the use of this 15 position. Okay, and then I also include to write just one letter to LCD, but this time I clear the LCD first, and then I want to write at line 2. So I change the cursor to line 2, position 1. Line 2, position 1 means it will write down here at line 2 at this position first. Okay, so now and then what it will write is it will write the character E, character N, and character D. So it will spell out N and wait for 300 milliseconds before it look back up to cursor 1 to hello world. So let's see the demo here. I'm going to run the program. So hello world, usually it shift from right to left, because we asked it to shift from right to left 15 times. So all the words are going to shift now 15 times. So each word is going to go from right to left. Okay, sorry, from left to right. Now whatever where you're sitting, sorry. Now and then it will shift back to enter back the screen. Okay, so if you look at the period of shifting, it will take roughly around 1 second, because we set the delay to 1000 milliseconds equals to 1 second. So LCD hello world and then N 300 milliseconds, 2 seconds, 1 2 3, and then it goes back to hello world. So hope this helped you to program your LCD. You can change the code following the instruction, and if you have any question, feel free to contact me.